Approximately 4 weeks, 5 weeks to get a person ready to get Journal Club up, and we've been able to put up a presenter every week since the start of Journal Club, and that's not been easy. Things happen, tests come up, people get sick, and in the last couple years, one guy has stepped up every single time something has gone wrong, and I just wanted to publicly and sincerely thank Mark for his contribution. I always start my presentations with thank yous. So, some dude actually trained me in Journal Club, right? And that guy is the guy who actually wrote this paper. Was the guy who showed me the importance of Journal Club, and I owe a lot to him. So I wanted to thank him. It's important in science specifically to remember that no matter how good any one of us are, that we're really nothing compared to those that came before us, and that we really stand on the shoulders of giants in this subject, and anytime anything good happens to any one of us, it's important to remember that there were many that came before us that helped us to get here. So this is a thank you to my Journal Club mentor, and I picked the paper, FXR is a molecular target for the effects of vertical sleeve gastrectomy, and let's get into it. So, the problem is obesity. I don't want to get into the numbers of obesity. I don't want to tell you how big of a problem it is, and I don't want to tell you the story of my friend today who has it, or anything like that. I thought that I would take a different tack today and show you how interesting it is. At its heart, many people think that obesity is a problem of willpower. That it is an urge to eat that you succumb to. And when you succumb to it, you become obese. But that's just not the case. So let's just look at a few players in the obesity picture. The brain is one of the most important ones. As I said, it was involved in that willpower aspect. But it's also involved in a lot of other things. So the way you carry yourself, whether or not your hand shakes, and your body temperature are all things that burn calories. They're not things that you're consciously aware of, but your body is a super finely tuned calorie sensing machine. It's able to sense 1 million calories in, that's about as many calories as you eat in a year, and put out the same amount of calories without you ever writing down how many calories you're putting in and putting out. The liver in obesity, right about here by the way, becomes fatty and can lead to some of the diabetic symptoms. The main culprit of obesity is adipose tissue, what we call fat. And contrary to what most people believe, it's not just like this dead sitting tissue. It is a highly organized storage mechanism. It also houses two of the most dangerous things in obesity. It houses inflammatory signals and things called macrophages. Now, macrophages are what destroy other cells in your body that are bad. So bacterial cells that aren't supposed to be there. And inflammatory signals are what cause your bruising or anything like that. But that's the link between obesity and cancer. Those signals reside in the adipose tissue. Guns, right? Muscles, also very important in obesity. They're what mainly drive or destroy fatty acids, fat. And then the often least thought of, but kind of most obvious, is like your intestine, right? Because if you eat a bunch of calories and you just poop them all out, then you're not going to become obese. There's got to be a mechanism by which calories get from the outside of your body, so what you put in your mouth, to inside your body. And that wall is the intestine. There's one thing in specific, or particularly that's important, and it's called bile. So bile is, if you take fat and you dissolve it in water, have you ever put butter in water? No. I mean, that's not oil in water. Oil and vinegar. Okay, so if you try to dissolve anything that is fatty in water, it won't dissolve. And you need bile to make it dissolve. And your body uses bile to bring fat in. Okay, so a lot of people associate obesity with a problem with weight loss. But it is not a problem with weight loss. Weight loss is easy. You can go to Maxim or Cosmo or Men's Health, any magazine right now, and if you put on like a stocking cap, start drinking lemon water with Tabasco and salt in it for a month, you will lose weight, right? There's a million diets out there, and they are crazy, but they work. They will get you to lose weight. The problem isn't in the losing of the weight. The problem is what happens afterwards. It's the rebound effect. The fact that you put the weight back on. That's the real problem in obesity. Despite the complexity of the disease and the number of people that have it, there's very little that can be done for obesity. There is no drug. Diet and exercise, while is the most common intervention, does not really work. You get the rebound. So one of the things that does work is a fairly radical procedure called a VSG. And what you do in a VSG is, this is your stomach. It's right about here, right here on the diagram, and blowing up, it's right there. Now, it looks like a balloon normally. And in VSG, what you do is you cut out about 80% of it, creating a tube in between the esophagus, the throat tube, and the intestine. The idea there is that if you reduce the size of the stomach, then you become full more easily, you eat less, and then you get healthy. So let's see if it works. These are two graphs. These are mice that have been fed high-fat diets, basically cookie dough. For 14 weeks, they were given the surgery at week 0. And the mice on the top got a fake surgery. The mice on the bottom got VSG. And you can see the mice on the bottom lost weight and maintained that weight loss for 14 weeks. I said that VSG leads to making you healthy, not just losing weight. So another aspect of VSG is the fact that if you have the same mice, the ones that didn't receive the VSG and ones that did, you'll find that they actually have lower resting glucose. So one of the key signs of diabetes is the amount of glucose in your blood when you're resting. And after the VSG surgery, you have a less amount. It's huge, actually. So VSG works. So, I like to talk about mechanisms. Cancer is the class that I teach is based on mechanisms, how things happen, why things happen. And interestingly enough, how and why things happen is, well, that search is really influenced by bias. Let's say I was a teenage girl. Let's say I liked a guy. Let's say I decided that if I got boots, let's say Bory Church boots, I would get that guy. Okay. And why did I get that guy? I got that guy because of my boots. That's what I might believe. Why? Because I like those boots. I believe they got me that guy. In actuality, was it that guy? No. Or was it the boots? It was my sparkling personality. My charm. Right? Scientists have similar biases. I actually like things, right? In fact, I have a favorite treatment. I don't know why it's my favorite treatment. I just know that anytime I see the neuroscience of like weight loss or smoking or depression, I kind of like it when it's this one receptor that's blocked by it's called the CV1 pathway, and I learned about it like when I first came into science. And so scientists found it because they actually studied people that smoked marijuana, and then when they blocked the thing that marijuana bound to, all these like wonderful things started happening. I just thought that was so interesting. So anytime I see neuroscience, specifically neuroscience of addiction and depression, eating or smoking, I like it when CV1 is the culprit. So let's look here. This is the slide I just showed you, right? Which one of these things could there be bias? Could be bias. Is it the size of the stomach after surgery? What do you say? What do you got?
People feel full.
People feel full, and then less food is consumed. That's got to be right. That's got to be right. We just reduced the size of the stomach by like 80%. If you feel full, then you would eat less. That's what weight loss. That makes sense, right? I mean, we saw this graph, and the glucose went down. It makes sense, except for one little interesting thing. The glucose reduction doesn't happen after weight loss. It happens the day after the surgery. So let me just make sure that you understand this. A person who is obese develops diabetes. They get a surgery, a very, very radical surgery. When they get that surgery, the day after, often the week after, they can stop taking insulin. It's not the size of the stomach. It's not the weight loss that drives this. It's too soon for weight loss to drive this. So, what happens when we start looking at something from an unbiased perspective? There's a technique called RNA-seq. And what that is basically a technique that allows you to look in the intestine or look at any tissue and just see the total amount of RNA being made. And you can look at changes in that. So what the scientists did is they took a mouse, gave it a fake surgery. They took another mouse, gave it the VSG. They looked at RNA in the bottom of the intestine. And what they found were these pathways were being changed here. Now, you don't need to know the pathways. But I'll tell you, a lot of them had to do with bile. And a lot of them had to do with the way bacteria process certain chemicals. Yeah? Yes, so they removed, immediately following the stomach, about 2 inches, yeah. They removed, it was a small segment. But all of these pathways converge on this one chemical called FXR, which has a very cool name. Now, if the stomach surgery influenced FXR, which influenced weight loss, then what would happen if we cut out FXR? You wouldn't have the weight loss. Any questions right here? I don't know. If FXR was driving the glucose improvement, then you shouldn't see that either. Right? Give me a thumb if you're with me right now. I get this. Put it right on your chest so nobody else can see it. And if you don't understand, aim it down. It doesn't need to go all the way down, but all right. I'm not sure I believe all of you. Let's look at that same graph. This is the same glucose graph that I've shown several times now. Okay. This is the group that received the fake surgery, this is the group that received the real surgery, and this is the amount of glucose, the change in glucose. But when the same surgery, fake surgery was done, with the same real surgery in a mouse that didn't have FXR, glucose actually got worse. One more time. This is the mouse that received the fake surgery. This is the mouse that received the VSG. Glucose dropped. Same scenario again, but this time there's no FXR. Fake surgery, real surgery, glucose got worse. Yeah.
Is it significant that in the knockout, starting for the ones that received the fake surgery is lower, the glucose level is lower?
Well, it sort of is significant, but they wanted to rule out the knockout as the actual process of the knockout as the thing that changed
change in between these two. You're right, the knockout mouse does have some differences physiologically, but they compared all the VSG surgeries to the VSG knockout. So there's never, you're looking at the change here versus the change here. You're never actually directly comparing this to this. Good question. Yeah.
When you say fake surgery, what was actually being done?
They did everything but remove the stomach.
Yes.
You mean like placebo surgery?
It's basically placebo surgery.
Yes. Why would you do that?
Well, Ms. Bartlett, they wanted to rule out the surgery itself as the effect, as the thing that caused the effects, right? So the weight loss, for example, you would see in anybody that receives surgery, whether it's a VSG or not, because you don't usually like eating right after surgery for about a week. Okay. Let's look at weight loss again. So this is the same graph I showed you earlier. This is the mouse that did not receive that receives this fake surgery, real surgery. And you can see that here, this mouse lost a lot of weight compared to that one. This is the effect of the surgery we were just talking about. So this weight loss right here is actually most likely an effect of the fact that they just got surgery and they're not eating anymore. Same situation, but no FXR. Weight loss occurs, but this mouse gains the weight back. I told you that obesity is not a problem of weight loss. It is a problem of weight rebound. And this indicates that FXR might have something to do with that rebound effect. Now, what's really going on? Well, when you look at the bacteria in the gut of the VSG mice, you find three major changes. And you don't really, this graph is not that important. All it shows is that there are three classes of bacteria, 1, 2, and 3. One population in VSG dropped significantly, another population went up, and another population went up. There were big changes in the type of bacteria that inhabited the intestines of the mice in VSG. Yes.
Why do you look at these three particular strains?
This is also an unbiased approach called UniProt. So they looked at total genomics and then sequenced it, and they got these changes. Good question. I passed the desk. So the new theory. What if it wasn't the fact that people felt full that drove all the benefits of VSG? What if it's this other pathway, FXR, via bile, that changes the type of microbes in your stomach, or in your gut, that drives a lot of these beneficial effects? Guys, we do not have the luxury of dealing with major diseases and making assumptions. We have to look at mechanisms over and over and over and over again. We need to know exactly why things are happening. So this whole gut thing, this intestine, like the bacteria in the gut, I started looking into it. And I did start doing this yesterday, unfortunately. But it turns out, if you take the gut flora, the bacteria in one person's gut, an obese person's gut, and you put it into a lean person's gut, you'll actually generate an obese individual. The same is true, not to the same degree, of lean versus obese. So if you take a lean person's gut flora and you transfer them to an obese person, then you will see a loss in weight. There are 100 trillion cells in this. From top to bottom, a human being is composed of 100 trillion cells. Only 1 trillion of them are human. The takeaway, the thing that I want you to get, the thing that I want you to remember above all else here, that there's a 99-to-1 ratio of non-human to human cells in what we call our human bodies. The diseases that we can't figure out, the big ones, the ones that have no cure, the ones that we just can't figure out, may have a huge basis in that 99% of the cells. to say that we are human and that we are going to treat these big diseases by looking at 1% of the cells because we're human is a bit pompous. I think we're more than that. We're not human. As a matter of fact, 99% of us isn't human. We are a collection of organisms. And I think that when we're looking at these big diseases, we need to treat ourselves like that. Question?
It's not a question, it's just a piggyback comment that it was said on the previous slide about how they thought people transplants.
Yes.
And they've actually started to do human trials for both Crohn's disease and Crohn's in the stomach.
Yeah.
So they take the feces of someone who's healthy, they process it, put it in a pill. The person who has the disease takes the pill, and they find out.
Yeah, I found a couple crazy ones. It turns out that the gut microbes can communicate actually directly with the brain, well, via our hormones. So the bacteria in your gut like influence your mood, influence your satiety. It's crazy.
Yeah, could you potentially make the same changes in ethics without doing the surgery?
So that's actually a really good question. They tried administering FXR to obese mice, but they found, and this was just done recently, but what they found was the effect was really, really different depending on where it was given. So they haven't been able to figure out where exactly to give it. As a matter of fact, they found it reversed. It actually made things worse when given, I think, in the side of the stomach. Yeah.
How does FXR interact with these different classes of bacteria?
The FXR changes biochemistry, which changes how fat's absorbed, which changes what bacteria is in your stomach. This is another question. This is another example of what you eat is really important, because as you eat healthy foods, your bacterial population changes. Last question.
You mentioned that the knockout mice that didn't express FXR were physiologically different. How so?
For some reason, generating a knockout produces a more lean mouse with nobody knows exactly why. It loses weight. Okay, Tommy?
I'm presenting in 2 weeks on a gene-specific role for the SSU72 RNAP2 CTP phosphatase in HIV-1 TOT transactivation. What that is TOT is a protein that stimulates transcription for HIV-1, viral transcription, and SSU72 basically it regulates termination, and TOT has been found to alter SSU72's function and make it regulate transcription rather than termination, which is interesting. So there's a role for SU72 HIV transcription, where it does not function.
Everybody, Tommy West. Guys, thank you for coming to Joe's Up. We'll see you in 2 weeks.